guys, in this lesson we are going to look at how to draw ray diagrams for a convex lens in physics. Now before we look into that, I just want to remind you guys that my online classes are still on, and I have a promotion at the moment where I'm giving a 50% discount. Instead of paying 100 quarter, you just need to pay 50 quarter and be part of my online class. And if you are interested, reach me on this line. Then what you need to have, just make sure that where you are, you have a stable network and a Telegram app in your phone. Right, now before we look at ray diagrams, first let's look at the convex lens. So the convex lens is also known as the converging. Then how can we identify, or how can we differentiate a convex lens from a concave lens? So you need to look at the structure and also what happens to light after passing through this lens. So this simple structure here represents the convex lens. So as you can see, it is thick on the middle and thin on the edges. Now I'm going to draw what we call the principal axis. So the principal axis is we can say, ray of light that passes through the center of this lens. So this is our principal axis. Now, after the principal axis, I'm going to draw two rays of light on top and two rays of light on the bottom. Now the question is, what will happen to these rays of light after meeting the lens? So they are going to converge. So according to science, physics, what is to converge? So to converge simply means to bend and meet at one point. So the point where these rays of light are meeting is known as the focal point. So this is our focal point. Then we have another point where the principal axis is meeting with the lens. This is what we call the optical center. Now, another terminology that we need to know is what name is given to the distance between the optical center and the focal point. So this is known as the focal length. And when drawing a ray diagram, if the question has not specified the scale that you are going to use, you can use a scale maybe of 2 centimeters, 1 centimeter, or 3 centimeters if the question is not guided. So now let's begin with our first ray diagram. So the first ray diagram, I'm going to look at where an object, so say object placed beyond to F. So what happens to the image and the characteristics of the image formed if we place an object beyond to F? So I'm going to first begin by drawing the principal axis. So this is my principal axis. Then in the middle, I'm going to draw my lens here. So like I said, if the scale is not given, I'll come up with my own scale. So I'll just say I'm going to be using 2 centimeters. So from here up to here is 2 centimeters. So this is this point. Let me put it somewhere here. So this point is my focal point number 1. Then somewhere here is my focal point number 2. Then if you are drawing this, please make sure you use a rule and you need to make sure that the focal length must be equal to each other. Now, what do we mean if we say an object placed beyond 2F? So an object placed beyond 2F, it's being placed somewhere here. So let me change the color, and I'm going to put my object here. So just say the object has maybe the height of 2 centimeters. So now, how can we draw the image? So what is your first step? So the first step is you need to draw a straight line until it meets the length. Then after that, bend by passing through the focal point number 1. Then number 2. I'm going to now draw another ray of light, but this time I just have to make sure that this ray of light passes through the center. It's not that straight, but because I'm using just free hands. Now if you use the actual scale and a rule, the image that will be formed will be between F and 2F on the other side. So this is our image. So that is what you have to do. Now let's look at the characteristics. So the characteristic associated with the image formed are: the first one, image is between F and 2F on the other side. So F and 2F. Number 2, image is larger than, not larger, smaller, is smaller than the object. We can tell that these two object and the image, they have different sizes. Then apart from the image being smaller than the object, we can see that the image is upside down. So what do we mean by upside down? We can see that the image is facing down. Then the image is real. Now, how can you know that the image is real? When it is facing the downward. Okay, so now we move on to, so what happens if we move an object and we place it at 2F? Right, so the same step, you draw the principal axis. After that, you draw the length in between your principal axis. Then you make sure that you use the same scale. So this is our F1. We have our F2. F1, F2. So now we move our object and we place it at 2F. So like I said, step number 1, you need to draw a straight line until it touches the length. After that, turn and make sure you pass through the focal point number 1. Then after that, you need to draw another straight line passing through the optical center. So the point where the two lines are meeting is where the image must be located. So if you use the actual scale, the characteristics that you are expected to have is number one, image formed at 2F. So the same. Then number two, image is same as the object. So in terms of the size, if the object is 2 centimeters, the image must also be 2 centimeters. Then the distance of an image. The distance of an image is equal to the distance of an object. I'm just going to write DO. The image is upside down, it's facing down. Then we can summarize by saying the image is real. Right, so this is what we are expected to do if you are drawing what we call a ray diagram. So what we are just doing is we are moving an object from one point to another, then also focusing on what is happening to the image formed. Now, let's say we move an object between 2F and F. So what happens to the image? So object placed at, let me not say at, let me just say between 2F and F. So as usual, you first begin by you draw your principal axis, very important. After that, you draw your convex lens in the middle. Then you need to put now the focal point with the same scale. Make sure you use the same scale. So this time we are going to put our object between F and F. So this is I'm going to put my object here. So step number one, you draw a ray of light. After meeting the lens, you turn and pass through the focal point number one. Then I'm going to draw another ray of light. Okay, so let me put the arrows. And a ray in physics simply means a path taken by light. So the point where these lines are meeting is where the image is expected to be formed. So this is our image. Now after this is done, look at the characteristics. So the characteristics, number one, image is larger than object. As we can see, they have different heights. Then number two, if we are to measure the distance of an object and compare it to the distance of an image, we can see that the distance of an image, di, is greater than the distance of an object, do. From there, we can say, what else are we going to say? The image is upside down. If that is the case, then we are dealing with a real image. And remember, there are calculations that are associated with a ray diagram. of which I'm going to make another video where I'm just going to focus on the simple calculations. Now, let's move on to now, if we place an object at F. So say object at place at F. So what I want you to take note of is the characteristics associated with the image, because they have to be in line with the calculations that we are going to look at in the next video. So make sure you stay tuned. So I'm sure by now you've gotten the concept, so you can feel free and pause the video, give it a try on your own, then after that you unpause and check if your answer is corresponding with mine. Right, so let me use a different color this time. So I'm going to use red. So we put our object at F. So this is our object. Now, the same way we did, I'm going to draw a line, touches the lens, then bend and pass through the focal point number 1. Then I'm going to draw another line. Now, if you just use the rule and the actual focal length, these two lines will never meet because they are parallel to each other. So the conclusion that you are supposed to make in a case like this one, you just have to say no image formed. So why don't we get an image here? Because the lines are not meeting. So that is the conclusion that we can make if we place an object at F, no image formed. Now let's look at the last one. So the last one is what we say object placed between F and convex lens. So if you are able to remember this and the characteristics of the image, then your calculations will make sense, because we can use calculations to know if the image is real or virtual. So I have principal axis again. Then I'm going to draw my lens here. The same. So we'll say focal point number 1, and second focal point number 1, focal point number 2. So our object this time will be placed here, because we are saying between F and the lens. Then what are we supposed to do? The same, I'm going to draw a line, a straight line, and so is this line. So as you can see, the lines, they are not parallel, but they are like spreading away from each other. So I'm going to now assume that we draw some dotted lines here behind the object. So as we can see, if we are to assume we are to draw this, the lines can meet at one point. So the point where these dotted lines are meeting is where the image is formed. As we can see, the image is larger than the object. Then the distance of an image is larger than the distance of an object, because if you measure this TI is greater than this DO. Then the height of an image is also greater than the height of an object. Then the other thing is the image is on the same side as the object. The image is upright, then we can conclude by saying the image is virtual. So if you find this video interesting, please give it a thumb, like the video, comment, and share with families and friends. And stay tuned for the next video. I'm going to focus on the calculations associated with ray diagram. So that's it for this video. Thanks for watching.